So this is a typical machine learning pipeline. You start off with collecting data. You process the data. You figure out what kind of algorithms you want to use. Sometimes you might have algorithms that you develop yourself, or you use deep learning frameworks. Then you train those algorithms. You tune your models. And when all of that is done, you are ready to deploy those models in production. But things don't end there. You still have to scale your application. You have to fine-tune your application. So all of this is complex process. And SageMaker can help in all of these different steps. We call SageMaker an ML platform for building, training, and deploying machine learning models. And as you can see, in all aspects of this ML pipeline journey, SageMaker can help you. We have services like Ground Truth, which help with data labeling. We have training platforms. We have online inference platforms. We have batch transformation as well. So SageMaker, all the multiple services, you can use all of them together, or you can pick and choose the service that works best for you. And there are customers who bring their own trained models, and then they deploy them on SageMaker endpoints and do online inference. There are people who just use batch transformation because that just works for them. They don't need the other parts of SageMaker. So SageMaker, you can think of it as sort of this set of different services, about 10 plus right now, and you can choose whichever is the best fit for your business. So let's look at machine learning pipeline again. ML is an iterative process, and what SageMaker brings to the table is the fact that in this iterative process, it will simplify the lives of your ML scientists. Vidhi just talked about experimentation with SageMaker Studio, and that's where SageMaker can help. After you train the model, there is an iterative process around debugging it, of figuring out how am I going to tune it, and as more data comes in, you have to train it back again. And once your model is trained, you have to deploy it. But again, as I said, you don't just stop by deploying the model once. You have to monitor it. You have to figure out if the accuracy of the model is still what you need it to be, or is it going down. And when it's going down, you have to send it back for retraining. And then, certainly, as organizations now have more than one ML scientist, they collaborate with each other, and that's where SageMaker Notebooks and SageMaker Studio helps. So, this typical ML pipeline that I'm showing here, it sort of hides a bunch of complexity that goes into developing models. You have to do feature engineering when you start off. The raw data you get is really not useful in itself. You have to throw away different columns from your tables because they don't make any sense when you are training a model. You might have to transform that data, pick out the features that are really useful, and all of that for feature engineering today you have to do yourself. And then once you have a model that's trained, you have to evaluate the accuracy of the model. And that's, again, there's a lot of compute involved in doing that. And then even once your model is trained and you have deployed it, there is feature transformation that needs to happen so that the features you're sending for inference actually match what the model expects. And again, more work for the scientists and the engineers in your organization. So data processing, is complex. Today, what our customers do is they're creating their own clusters on EC2, or they're doing it on-prem, and all of that is hard to do. If you're doing it on EC2, you're using Spark clusters. You're finding ways to prune all of that information without any help from SageMaker, and and that is sort of a blocker we see when we talk to our customers in terms of how they want to use SageMaker. They want it to work the same exact way as training works, as batch transformation works. And that's why we have introduced SageMaker processing jobs. So what processing jobs really let you do is, in a very managed environment, using the same APIs that you're used to for training, you can create SageMaker processing now. And you can use the same APIs that which look very similar to how you do training today. And we create the clusters for you. You can use the containers that we provide to you, or you can bring your own container. And all of that can happen inside of SageMaker. You don't have to change any security policies. You don't have to do lift and shift of data from Redshift or use Glue or EMR. All of that can now happen inside of SageMaker. So let's look at the next thing that you have to do around as an iterative process in machine learning. Let's look at the debugging aspect of things. So today, it's easy to debug a model that's, statistical model that's lightweight. And, for regressions or for categorical data, we're using, simple algorithms. You can log the information and figure out, what's wrong with your model. But that gets hard, really, really hard when you're using deep learning frameworks. I mean, imagine a deep learning network which has hundreds of hidden layers with tens of neurons inside it. How are you going to debug that? And what basically people are doing today is they're running the training, and after hours of that training being run, they come back and find either the model did not train, or if it trained, it's not accurate enough, and then you start all over again. And that's so debugging of deep neural networks is a really hard problem, and that's what we have tried to solve by including SageMaker Debugger. SageMaker Debugger is a capability which, with a single click, what it does, it lets you switch on debugging of your neural networks. So you can capture the data with a single click. All you have to do is to say, as part of my training when it's starting, I'm going to capture all the data from my tensors, from my scalar data, and send it to an S3 bucket that's owned by you. And what we do with that is we analyze all the data. We have 18 plus rules which go through the data in near real time. What's basically happening is we are processing the data asynchronously. We are finding issues with the training that's taking place. And we could find things like, if we have exploding gradient or vanishing gradient, all of that information will report back to you. We'll even report back things like, the CPUs or GPUs are not getting utilized. And all of that is sent back either through the SageMaker Studio that you just saw, or through CloudWatch alerts. And so that you can basically then decide what to do next. It could be that you have to go back to the drawing board, create a new neural network, or you can fine-tune the network itself. So all of those all of that is possible, and it just saves you a lot of time and effort in doing that. And one of the coolest thing about this is if you're using the inbuilt rules, the additional processing that's taking place, you're not getting charged for it. All the processing we are doing is in T3 medium EC2 instances, and that processing, we are doing without any charge, in addition to what you're already paying for your training. So here is a screenshot of the SageMaker Studio, where you can basically see in this notebook that I'm creating a TensorFlow estimator, and I've specified 3 different rules. 2 of those rules are inbuilt rules, And the third one is a custom rule that I've created saying, for my specific neural network, I need to also look at that specific problem. And all you do it after that is you kick off training. And on the right side, you will see that we are, as the training is running, we are analyzing these tensors. And we are reporting back that, that analysis is still in progress. And on the bottom side, you will see that we are also visualizing if the loss function is improving or not. All of that information is available to you from SageMaker Studio. So here is another screenshot. Here, basically what we are doing is you're able to then compare multiple trials that are taking place. Trials basically mean training jobs that are happening. You can basically compare how well one is doing versus the other with all the information that's being collected from these, from the scalar and tensor values. So in this specific case, you can see that on the top left, we are showing there is a vanishing gradient problem with your neural network. And you get this information here. You get the log results, as you can see on the right side of the pane. But also, the cool thing is you don't have to come always to SageMaker Studio to get that information. That is spent through CloudWatch alerts, and you can alarm on those, and you can basically, at that point of time, the training can stop. And instead of the training run going for days before this is found, within maybe minutes or hours, you can realize there is a problem with the neural network you have. So let's look at the next stage in this ML pipeline. Yes, you have a trained model now. You want to go ahead and deploy it. And one of the things you do want to do is to figure out that if the accuracy remains the same over time, or if there is a model rot where over time, because things are changing, the accuracy is going down. And that's challenging today. I mean, it's challenging because there are no tools available. You have to figure out your own way to collect all the inference data, figure out how the inference is changing, and then take steps. And as a result, what customers do is they either do not retrain their models, or they set up some frequency of training. It could be like every few months, I'm going to retrain my model because I really don't know when I should retrain them back. So that's where a new capability called SageMaker Model Monitor would help. This is a new feature we launched at re:Invent a few weeks back. And again, it's as simple as the debugging aspect, where with a single click, you can say, switch on monitoring on my inference endpoint. What happens when you do that is we will go ahead, start collecting all the data that's there on your inference endpoint. We collect all the inputs that inference call receives, and the result that was sent back. And it all goes, again, into an S3 bucket that's in your account. And after having said that logging of data, what you basically do is you say, OK, let's create a baseline of what my feature should look like. What is the value of the feature? How many features I have? Or if there are a specific feature that always exists or not. You could also say, this specific feature should have a range of values, maybe from 0 to 100. And if it's outside of that, that's a problem. Or you can think in terms of standard deviation of your feature. And what will happen once you set that baseline? SageMaker Model Monitoring knows what to look for. If over time it sees that the value of some of these features is not what was expected to be, at that point of time, it will again alert you. It will, you can use CloudWatch alert for that, or you can go back to SageMaker Studio, and you will get all that information again in SageMaker Studio. So there are multiple ways where model monitoring can be really compelling, and again, save you the cost of having to find these, later when your business is suffering because the model predictions are not being accurate. And another cool thing about this is, same as Debugger, where if you're using the rules that come inside the box of SageMaker, you don't have to pay for the processing that's happening to generate these alerts. If you write your custom rules, which you can, at that point of time, you pay for the additional processing cost. But out of the box, you can just set it up, and with a schedule, it says, the default schedule is every day, at some point of time, it will go process through all the data that has been collected, and then it will send an alert saying, there is a problem, there is a concept drift, or there's an issue with your features. And then some of our customers, what they do is they get the alert, they trigger retraining and send their models back. So that's certainly something to look at. So this is a screenshot of some of the endpoints you can see on the left in SageMaker Studio, and it shows that they are all active. On the right-hand side, you can see that we are collecting the data and then visualizing the features. In this case, for a single feature, we are looking at the sum of the values over time. And you can see the baseline value was supposed to be 200 plus, and it's spiked up. And in that case, if it goes beyond a specific threshold, we will go ahead and send an alert. So this screenshot of the SageMaker Studio shows all the monitoring runs that we have done. In this case, they were, we are showing that it runs on an hourly basis, and all those monitoring jobs information is collected, and you can double-click on any of those, and you will get the details of that specific monitoring job. And on the right pane, you can actually see the information about the specific features that were evaluated as part of that monitoring job. So we talked about all the features we launched at reInvent, but we launched a few really cool and compelling features over the last few weeks before reInvent, and I just wanted to quickly cover those as well. So one of the customer asks we have kept on getting for the last 2 years since SageMaker was launched was integration with Kubernetes. There are a lot of organizations who have Kubernetes running. They might be doing orchestration with Kubeflow or with some other CI/CD mechanism, and they want to have SageMaker be part of that. And so we launched SageMaker operators for Kubernetes. What that allows you to do is basically, from Kubeflow or using kubectl, you can basically say, I want to start training using SageMaker, not using the Kubernetes cluster I have that I'm managing myself, but let SageMaker do the management of this training process. And once you call these operators, which are nothing but custom resources, we will create the cluster in the backside. We will, after that, the training will run, and that cluster will be decommissioned after that. And again, you pay only for the time the cluster was up and running and doing the training for you. Similar is for inference, where we would go create the inference endpoints. And after the inference endpoints are created, you start getting all the information back to your Kubernetes cluster about what's going on with your endpoints. Another challenge that a lot of customers face is, they have a lot of small models, few kilobytes of models. And some of them have a large number of those. In case when you have models that are personalized to each and every customers of your business, you could have tens of thousands of models. And that makes it hard for you to host those, right? Because you can't have an inference endpoint for each of those models that you are paying for each and every EC2 instance, or if you're managing yourself, your compute costs just skyrockets. And to solve that problem, we launched multi-model endpoints in November. The idea being that behind a single endpoint, you can have tens of thousands of models. And we make sure to bring them up in memory of the instances of the endpoint as and when they are needed. And if the usage goes down, we will push them back to storage, and a different model will be running in memory. So you can have a significant savings by using multi-model endpoints. So one of the things that is a challenge with training is if you're doing distributed trainings of neural networks, that training can go on for days, and all of that compute is costing you a lot of money. And to help with that, in a few months back, we launched the ability to use spot instances for training. If you don't really care about the training getting over quickly or within the next day, you can use this capability. We will kick off the training when spot instances are available and shut it down when spot instances go away, and pick it back up when the instances become available again. So one of the questions that I get asked very frequently is, yes, SageMaker has a lot of interesting features, but what about the TCO? What about the total cost of ownership? And how we think about cost of ownership is, for your ML scientists and your engineers, what all work they have to do if they were using raw compute or if they're using EC2 versus using SageMaker. I mean, if you look at the fact that you have to manage your own infrastructure if you're using EC2, not only are you paying for your resources, you also have to worry about if those resources are always utilized or not. Otherwise, you're wasting money. And as part of the operations, you're making sure the EC2 instances stays up all the time. You have to make sure your application is healthy. You have to make sure everything is running well. And then, a lot of our customers have security and compliance requirements. If you are working in fintech, you can't have just your model up and running without taking care, really locking it down. And all of that adds cost and takes a lot of effort. So we did some, SageMaker and Amazon did some calculation in terms of, the savings that customers can get out of using SageMaker compared to if you were doing a self-managed, machine learning pipeline. And we believe that you can get up to 96% saving in total cost of ownership if you're using SageMaker. And on top of that, a huge productivity gain for ML scientists. So the last slide is just about the takeaways from this presentation and Vidhi's presentation. Make sure to try out the new features around SageMaker Studio, SageMaker experiments, and see how they can be helpful for your organization. Try and use all the features I talked about today: processing jobs, debugging, monitoring. All of those things are really compelling and are going to really help your ML pipelines. And last but not least, TCO. Think about SageMaker from a feature perspective, but also from a total cost of owner perspective.